On November 5, 2025, the Virtual Telescope Project released two new images of the interstellar object 3I Atlas, and what these images revealed further puzzled the scientific community. In the photographs, 3I Atlas appeared as a compact source of light, showing no signs of a cometary tail. Even more surprising, the object's appearance was virtually unchanged since it was observed by the Hubble Space Telescope in July 2025. According to calculations by Harvard astrophysicist Avi Loeb, the object should have lost at least 13% of its mass. That's more than 5.5 billion tons of material. But the absence of a massive and bright coma is simply inexplicable. For comparison, the same images captured Comet Lemon, an ordinary comet from our solar system. Lemon looked exactly as expected, with a clear and bright tail pointing away from the sun, formed by the pressure of solar radiation pushing gas and dust into space. 3I Atlas, however, remained mysteriously clean, without the visual signs that should accompany the mass loss required to explain its non-gravitational acceleration. According to Loeb, this is further evidence that 3I Atlas is not behaving like any known natural object. And this leads to a fundamental question that science needs to seriously address. There has been a lot of misinformation and panic surrounding 3I Atlas and its acceleration. In this video, we'll analyze the actual data and determine if it really could indicate something unusual within our solar system. On October 29th, at its closest approach to the Sun, 3I Atlas began to accelerate in a way that cannot be explained by gravity alone. NASA's Jet Propulsion Laboratory presented a report stating that 3I Atlas was 4 arcseconds further from where it should have been, according to gravitational calculations. This may seem insignificant, but when you're tracking an object 203 million kilometers from the Sun, this deviation is enormous. The object is accelerating at approximately 0.2 mini-s2. For comparison, in just 1 month, this small acceleration shifted 3I Atlas from its predicted trajectory by approximately 80 kilometers. The acceleration has two components. It is pushing the object away from the Sun at a rate of 135 kilometers s2, which is about 60,000 kilometers per month. And it's also moving sideways at 60 kilometers day 2, adding another 27 kilometers laterally. So, this object isn't simply drifting in one direction. It is being pushed both sideways and outwards simultaneously. Now, before anyone panics, this acceleration isn't bringing 3I Atlas closer to Earth. The deviation isn't large enough to alter its trajectory towards any planet in our solar system, except for Jupiter, which it is expected to reach in March 2026. So, what is non-gravitational acceleration? Imagine it this way. When you throw a ball, gravity pulls it down in a predictable path. But if that ball suddenly had small rockets firing, it would deviate from its course. That's what's happening here. 3I Atlas isn't following the trajectory that only the Sun's gravity could create. Something else is pushing it. For a comet, the natural explanation is outgassing. When ice heats up near the Sun, it turns into gas and acts like a rocket engine. This is perfectly normal for comets. The problem is how much gas 3I Atlas would have to release to create such an acceleration. And that's where things get really interesting. Harvard astronomer Avi Loeb performed calculations using basic physics. If you know an object's acceleration and mass, you can calculate how much gas it needs to release to create that acceleration. 3I Atlas weighs at least 33 billion tons. This is a massive object compared to the first two interstellar objects we discovered. It is 1,000 million times more massive than Oumuamua or Borisov. Its core is estimated to be about 3.5 miles, or nearly 6 kilometers, across. With that mass and that acceleration, the calculations reveal something astonishing. To create such acceleration through natural outgassing, 3I Atlas would need to lose at least 1/6 of its mass per month. At its closest approach to the Sun, that's at least 5.5 billion tons of gas. That amount of gas would create a massive and incredibly bright cloud around the object, impossible to miss with our telescopes. From late November 2025 through the end of January, dozens of ground-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, are observing 3I Atlas. On December 19th, it will approach Earth to a distance of 167 million miles. If that massive gas cloud is there, we will see it. But what if it isn't? That's where the scientific discussion gets really interesting. If we don't see this massive gas cloud, then the natural explanation fails. If there's no cloud corresponding to the amount of gas needed to create such acceleration, then we must seriously consider that the acceleration is caused by something else, something technological. The fact is, we've seen this picture before. The first interstellar object also showed non-gravitational acceleration, but it released no gas or dust. Even the ultra-sensitive Spitzer Space Telescope couldn't detect any outgassing. Scientists ultimately called it a dark comet, which is essentially an oxymoron. A comet's defining feature is its tail of gas and dust. But 3I Atlas is showing us something even stranger than Oumuamua. It exhibits two additional odd behaviors that make accepting a natural explanation even more difficult. First, there's the brightness problem. As 3I Atlas approached the Sun, its brightness increased according to a power law with an exponent of 7.5. For those unfamiliar with the math, here's what that means. Normal comets get brighter as they approach the Sun, following a power law of between 2 and 3. 3I Atlas is getting brighter, much faster than any ordinary comet. It's increasing more than twice as fast as expected. This is completely unprecedented. Second, and this is the 9th anomaly on the 3I Atlas list, it is blue. It appears bluer than the Sun itself as it approaches. This is very strange because dust usually makes objects appear redder, not bluer. The surface of 3I Atlas would have to be approximately 20 times colder than the surface of the Sun. Cold surfaces don't glow blue, they glow red. So, why is it blue? Natural explanations include ionized gases, such as carbon dioxide, emitting light directly. This is possible. Now it's important to understand what's really at stake here. Scientists aren't claiming that 3I Atlas is definitely alien technology. The debate is about scientific methodology. When you have data that doesn't fit your theories, you can't simply dismiss it. You must take it seriously and explore all possible explanations, even the uncomfortable ones. Some scientists have suggested that the data must be wrong because they couldn't explain it. Dr. Avi Loeb told them that this is terrible science. You can't say that data is wrong simply because you don't have a suitable theory. 3I Atlas is a unique object in our solar system that highlights not only the facts, but also their significance and why each of them challenges current understanding. Unlike anything we've ever seen, it exhibits a variety of anomalies. Among them, the first anomaly is an impossible path. 3I Atlas travels on a line that deviates by only 5 degrees from the plane in which all the planets revolve around our star. Imagine a table on which all the balls roll at the same level. This is the plane of the ecliptic. An object coming from another star system should appear from any random direction in space, like a ball thrown from afar, which can fly from above or below from any side. But 3I Atlas appeared almost perfectly aligned with the plane of the planets. The probability of this happening by chance is only 0.2%, like hitting a tiny target in the dark. The second anomaly is the jet engine that defies physics. In July and August 2025, 3I Atlas did something that has never been seen in nature. It created a jet of matter directed straight toward our star. All known comets do the opposite. They always create tails that point away from the sun, like hair blowing in the wind as you run. This is a basic law of physics. Solar radiation pressure pushes matter outwards. 3I Atlas broke this fundamental rule, as if someone is running, but their hair is blowing against the wind. The third anomaly, too big and too fast. 3I Atlas is 1,000,000 times more massive than Oumuamua and 1,000 times larger than Borisov, but still moves faster than similar objects. This is like seeing a giant truck overtaking race cars on the highway. Larger objects in interstellar space usually move slower due to the gravitational forces that push them out of their original systems. 3I Atlas violates this rule with very low probability. The fourth anomaly, too precise timing. 3I Atlas arrived just in time to pass near Mars, Venus, and Jupiter, but remained invisible from Earth at the most important moment, perihelion. It's as if a tourist visited 3 important cities in a country, but managed to completely avoid surveillance cameras at the main airport. The temporal precision of this sequence is extremely rare, less likely than winning the lottery. The fifth anomaly, factory composition. Spectral analysis revealed that 3I Atlas has much more nickel than iron, which is typical of metal alloys produced industrially on Earth. Natural comets should have a random mix of metals, like a soup of cosmic ingredients. But 3I Atlas has a special recipe, as if someone carefully selected the ingredients. The probability of this particular composition arising naturally is very small. The sixth anomaly, dry as a desert. Comets are known as dirty snowballs because they are 80–90% water ice. 3I Atlas is only 4% water. It is drier than many deserts on Earth. It's like finding an iceberg that is almost entirely made of rock. This characteristic calls into question the very definition of a comet, suggesting it may be an unnatural comet. The seventh anomaly, impossible polarized light. Atlas showed a polarization of light that has never been seen in any known natural object. Polarization is like a fingerprint of light. Each type of surface creates a unique pattern. It's as if 3I Atlas had a fingerprint that isn't in any natural file, including all comets ever studied, even Borisov. The eighth anomaly, connection to the 1977 mystery. 3I Atlas arrived from the same direction as the famous WOW signal of 1977, the most mysterious radio signal ever detected, which many consider the best evidence of extraterrestrial communication. The accuracy of the direction is impressive, as if 2 events separated by almost 50 years point to the same cosmic address. The probability of such a coincidence is very small. The ninth anomaly, hotter than our star. Now, 3I Atlas appears bluer than our star, suggesting that it has an internal energy source hotter than the sun's 5,800 degree Kelvin. It's like finding a candle that shines brighter than a bonfire. This points to a technology capable of generating temperatures higher than our star, which is completely beyond our current capabilities. The physics are clear. Strong acceleration requires a large loss of mass. If we don't see the gas cloud that should accompany such a mass loss, only one explanation remains that fits the data. As we approach December 19th, when 3I Atlas reaches its closest point to Earth, hundreds of telescopes will be searching for the 5.5 billion tons of lost gas. If that gas isn't there, we'll know it's not a comet. We will be seeing something far more extraordinary. Technology from another world, demonstrating propulsion capabilities that challenge our understanding of physics. The countdown has begun to potentially the most significant discovery in human history. In just a few weeks, we'll know if we're truly alone in the universe, or if we're currently observing our first confirmed visitor from the stars.